This video is to go over an example of how to re-express one trig function rather in terms of another, which is another way of referring to as an identity. And we're also using these trig identities that you were introduced to in Chapter 5, the Pythagorean identities, which are based on the Pythagorean theorem. Your sine squared theta plus cosine squared theta equals 1. And then the two versions of this identity that pop out when we divide by either cosine or by sine. If I divide sine squared theta by cosine squared theta, I get tan squared theta. Same if I divide by cosine squared theta, I get 1. If I divide by cosine squared theta, I get secant squared theta. And then similarly, this is what comes out if I divide everything by sine squared theta. So those are the three versions of the trig of the Pythagorean identities. And then we have these two kind of simplified versions, right? That if we just want everything in terms of sine or in terms of cosine, we can simplify the original Pythagorean identity into this form. Okay, so we did do these in Chapter 5. There was actually a test question on these, and I even did one in class, but I'm going to work one of these anyway because a lot of you did have some trouble with this. So this would be the example here would be express the tan of theta in terms of sine of theta in quad 2. Okay, and here we are also going to use, our positive little all students take calculus acronym that may or may not be true, but that all the functions are positive in 1, sine and its reciprocal are positive in 2, tan and cotan positive in 3, cosine and secant are positive in 4. Okay, so we start out by re-expressing the tan of theta in terms of sine and cosine. So we could say tan of theta is equal to sine of theta over cosine of theta. And looking at this means we need to replace sine of theta with, or cosine of theta with a form of sine of theta, which will be this up here. So we're going to take sine of theta is fine. It's this one that's a problem. We're going to use the plus or minus 1 minus the sine of theta. We're just doing substitution. And then the last thing we need to do is say, hey, what sign do I need? And then what sign will I get if I plug this in order to determine whether I have a plus or a minus? Okay, so we'll go through one at a time. Tan of theta in quad 2 will be negative. So I need a negative out of this expression, okay? In quad 2, sine of theta is positive. Therefore, this expression down below must be negative in order for me to get a negative of tan, which means that I'm going to have a negative in front of that. And so that is the answer. It might a little bit more typically bring the negative up, but if you did the negative in the bottom, I did not penalize you for that on the test. Either one of these answers would have been acceptable, okay? So that's pretty much a quick, review. You will be asked, I think it's problems numbers 60, 61 and 62 that do ask you to prove these two identities. And again, what the proving basically says, this is going to be something we'll be doing a lot of in Chapter 7. To prove something, what you're going to say is, prove that your sine squared theta plus cosine squared of theta equals 1 if, well, actually, what we could say is that prove that this is the same identity as this. And of course, we're going to get to that by doing all the divisions. So you're just going to essentially show that algebra that if I divide everything by cosine squared theta, I get this identity, okay? Okay, so you might even be asked to do this to express a reciprocal function in terms of another function, right? Okay. And so this is problem number 42. 2. If I wrote this correctly, and I didn't, it's going to be in quad 1. And part of me thinks maybe I might redo this one in a different quad, but we'll play this one out. And again, I'm just going to go back to that same thing. I'm going to re-express this secant theta as a sine or cosine function, okay? Secant is the same as 1 over cosine of theta. And then to get that in terms of sine theta, that's the same as 1 over plus or minus the square root of 1 minus sine squared of theta using this substitution here. And then I have to think, well, in quad 1, this is super easy. This is just going to be plus because I want everything to be plus. Let's think about this. What if it was, I don't know, quad 4, okay? What I have to think about then is, right, my all students take calculus, all right? Secant is the reciprocal function of cosine. So that means that it should be positive. So again, whether it was in quad 1 or quad 4, I'm going to have a positive here. That's going to be my final answer right there. Okay? Numbers 43 and 44, just be sure that you don't reinvent the wheel here. Number 43 says that you want secant theta in terms of tan theta, and that's in quad 2. And basically, rather than expressing this in terms of sine and cosine, don't forget, I can go directly to this identity here. So I could say that secant of theta is going to equal plus or minus the square root of tan squared theta plus 1. And then all I have to think about is in quad 2, okay, secant is the reciprocal of cosine. That means it should be negative, which means I'm going to choose the negative version of this, okay? So I'm going to leave you to do 44 on your own, and that should get you guys good to go on those.